You know that feeling, right? That flash of insight, that brilliant idea that feels like it could change everything, only for it to just fade away? Well, today we're diving into a powerful blueprint for taking those fleeting moments and turning them into real, structured, testable universes. Let's get into it. I mean, seriously, where do they go? They pop into our heads on a walk, in the shower, those quiet moments, and then poof, they're gone. They die from neglect, really, from a lack of structure to hold them, to give them some kind of shape. But what if they didn't have to? And that really gets to the heart of the problem. A raw epiphany, it's like a comet of thought. It's bright, it's exciting, but ultimately it's just passing through. It doesn't matter how brilliant it is. If you don't have a framework to capture it and polish it, it just vanishes. So here's the path forward. It all starts with that raw epiphany, that initial spark. But then, and this is the crucial part, we give it structure. We talk about it, we model it. That sharpens it into a testable hypothesis. And then the fun really begins. We bring that hypothesis to life in a simulation, our very own software playground where the idea can run wild. This quote just nails a really important mindset. We're not trying to build some rigid, perfect dogma right out of the gate. The goal is to create flexible scaffolding for our thoughts, a model that's meant to be tested, to be bent, maybe even to be broken. Because honestly, it's in the cracks where we usually learn the most. And what this whole process lets us do is build something way more dynamic than just a simple hypothesis. We get to build a living, breathing, miniature universe for our ideas. So why do we need a playground? Well, think about it. Testing ideas out in the real world is messy. It's slow, it's super expensive, and the feedback you get is noisy and confusing. But a software simulation, that's our own personal universe where we control the physics. We can run experiments at machine speed for a tiny fraction of the cost. And this is where things get really cool, because modern AI is basically a scientist's dream come true. We can populate our little universe with what we call synthetic personas, AI agents that we seed with different beliefs, different strategies. Then we just hit fast forward, generating months of simulated interactions, and see what happens. We're not just coding rules anymore. We're literally watching a synthetic society emerge. And the scale here is just staggering. Imagine you want to see how a new idea might perform over a whole quarter. Instead of waiting 3 real months, you can generate all of that data almost instantly. This lets you validate your hunches and show a really compelling what-if story before a single line of production code is ever written. So you can see this is so much more than just a demo or a prototype. What we're creating is a living laboratory. It's a method for turning those flashes of insight into worlds where your ideas can collide, evolve, and actually be measured. This is where philosophy and engineering really shake hands. Once you start building these miniature universes, you might start to notice something a little strange, a weird echo, a kind of rhyme between the structure of your code and, well, the structure of the cosmos itself. And that simple observation leads us to a really profound question. If our little simulation is a miniature universe, what does that say about the one we're actually living in? Okay, check this out. This is the grand analogy. Think about our software's database, its state store. That's kind of like the total state of the universe, all the information about every single particle. And our business logic? That's like the fundamental laws of physics, gravity, electromagnetism, the rules that change one state into the next. And our user interface, our API? Well, that's conscious observation itself, the senses and tools we use to actually ask reality, what's going on. Now, this isn't just some wild idea we cooked up. It taps into a really deep concept from theoretical physics, captured perfectly by John Archibald Wheeler's famous phrase, it from bit. It's this provocative theory that the physical world, the it, actually emerges from information, from binary choices, the bit. But, and this is a big but, let's be super clear here. This is a metaphor. It's a tool for thinking. It is not a literal blueprint. We don't have proof that the universe runs on some kind of cosmic SQL server. But thinking about it this way is an incredibly powerful way to sharpen our reasoning and find new ways to explore how the world is put together. Okay, so the software stack is a fantastic starting point, but it's not the whole story. It has its limits, so now let's explore some other core patterns, some new lenses for trying to understand the deep structure of reality. Any good model has to know where it breaks down. And the software stock metaphor, it kind of struggles with the continuous flow of time. It has a really hard time with consciousness, and it doesn't really account for the fact that we're inside the system we're trying to observe. Plus, it has trouble with the beautiful messiness of emergent things, like life itself. And this is where things get really mind-bending. Look at how these deep, ancient philosophical ideas are perfectly mirrored in the everyday tools of computer science. The idea that reality is just a collection of discrete facts, well, that's a table or an array. The idea that it's all an interconnected web, that's a graph. That it's an unfolding computation, that's an automaton. It's like computer science has accidentally built concrete versions of humanity's oldest models of reality. A great example of the computation model is Stephen Wolfram's famous cellular automata. He showed how unbelievably complex, even lifelike patterns can emerge from just a few super simple local rules on a grid. There's no grand architect, no central database, just simple computations unfolding, one after another, creating a universe of surprising depth. Okay, that was a pretty wild ride, right? We went from a simple idea all the way to the fabric of the cosmos. So let's bring it back down to earth. Why does any of this deep structure stuff actually matter for what you do? Because it reframes everything. The act of building software, or structuring an argument, or designing a system. It stops being just a technical task. You're actually participating in this incredible, age-old human quest to find patterns and make sense of reality. And these metaphors we've talked about, facts, relationships, computation, and so on, they're not fighting each other for the truth. They're just different lenses, different ways of looking at the same deep mystery. The most powerful thing you can do is not to pick one, but to know when a problem needs you to switch your perspective. And this all boils down to the most practical takeaway. When you choose to model a problem with a table instead of a graph, you're not just making a technical choice about performance, you're making a conceptual choice. You're deciding to view that piece of the world as either a tidy ledger of facts or as an interconnected web of relationships. And all of this, it just points to this profound sense of wonder. The physicist Eugene Wigner famously talked about the unreasonable effectiveness of mathematics, this baffling, astonishing fact that a language of pure abstract patterns can describe the real physical world with breathtaking accuracy. What we've been exploring is that very magic, that deep current of structure that runs through our code and the cosmos. So, that leaves us with one final question for you. This framework, these metaphors, they're not just for observing the world, they're tools for building in it. So if reality really is woven from these deep patterns, from a kind of source code, what new ideas, what new systems, what new miniature universes are you going to build with it?